installation, what is the latest? Any problems to be discussed? Great. So if not, let's start the lesson. On the last day we couldn't do due to power issues. On the previous day we were just discussing the Oracle instance architecture. We didn't start it. We just went through the shutdown and startup commands and getting familiar with very basic stuff with Oracle database. Now today let's start deep dive in the Oracle instance architecture. Let's deep dive the Oracle instance architecture. So that's why actually I just wanted to cancel the last day lecture. Even the university has requested because due to the power issue, because the lesson that we were supposed to do will be critical. The lesson was a little bit critical because you need to understand this one well, Oracle database architecture. So let me share the screen. Okay, so can you see the screen?
Yes, sir, we can see.
Yeah, good. I will share this presentation with you. This is there in the channel, but still in the channel I haven't shared the presentation. But I will share it with you via LMS. You can get it. So I'll be using this PPT animation one to explain the stuff. Non-multi-tenancy architecture deep dive. Now that is what we are going to focus on initially about the non-multi-tenancy architecture. Now I think some of you had some questions initially about this containerization and multi-tenancy. We discussed I think around 2 weeks back. So Oracle has both architectures. I was explaining this one, multi-tenancy architecture, non-multi-tenancy architecture. So non-multi-tenancy architecture is the previous one actually. It has been there from the beginning, from Oracle 6, 7 up to 12c. Up to 12c, non-multi-tenancy architecture was there. From 12c onwards, because this cloud, then only this cloud applications, people are moving to cloud, the demand was very high. Then the requirement came something called multi-tenancy architecture. Multi-tenancy architecture. So starting from Oracle 12c, it is supporting both non-multi-tenancy and multi-tenancy, both supporting. So we will not get into the multi-tenancy at once because it is highly important to understand the generic architecture, that is the non-multi-tenancy architecture. Then after that, I will just give you idea about this, what is the multi-tenancy and all, which is the future of your Oracle career. Great. So actually multi-tenancy is the one which is there on the cloud and it is supporting the containerization architecture as well. But before understanding that, we need to understand the standard architecture, that is a non-multi-tenancy, because within the multi-tenancy, non-multi-tenancy architecture is there, embedded. It is there because we can't get rid of this non-multi-tenancy architecture. So let's get familiar with that. Let me put it fully screen. Great. Journey of Oracle non-multi-tenancy database architecture. Now, I think theoretical understanding with definitions, all about memory architecture, all about process architecture, physical database architecture, client-server communication, architectural components, interaction with step-by-step SQL step and workflow, checkpoint mechanism, DB writer, log writer conditions, multiplexing, redo log files, optimal log files, and there are a lot of things. But don't worry, we are not going to cover entire stuff for you because learning platform has all of those things explained. Now at the moment there are 31 sessions. Architecture sessions 31ක් දාලා තියෙනවා learning platform එකේ. We have 31 sessions and still continuing. So it's a very big lesson, but I'm not going to cover entire thing for you in this in this lecture series, but let's get familiar up to a middle level. That is enough for you at the moment. But later you can deep dive with the channel. Great. So let's try to start this one very first starting thing. The documentation reference also I have given. Oracle database server. Okay, now let's start from here. Now you may remember on the last time, if I just switch back to my practical environment. Yeah, this one we had these two. I think we were doing our practicals. Let me just clear screen. Can you see the screen? I switched to Linux environment. Is it visible properly?
Yes, sir, we can see.
Great, right. So let me just get the name. I think we are familiar on this command, show parameter name. This is nothing much, just to get the name. Now, if you have the hands-on environment, you can do it with me. කරන්න පුළුවන් නම් do it with me together. So I am connected to a 19C database, and just to revise our command, select status from $, instance, database is open. Now we know these things. Now we basic commands we already have done, but still we don't know what is the instance, what is Oracle database in detail. We don't know those things. Now that's why starting from today, we need to start our phase 2 of understanding, deep diving inside the instance. Now again, if I just recall, we know the shutdown command. We just ran shut immediate. We ran several commands. Again, you notice when you're shutting it down, it is going through some steps. Very first thing it will say database close and dismounted, and again finally say instance. So now we need to understand what's happening in between these steps. Now we know it's giving some output, but we don't understand. So let's try to get those ideas a little bit detailed. Instance shutdown. Yeah, now that's why it says instance shutdown. Yeah, that's it. But we don't know what's happening behind. And again, even if I start up the command, I'm just quickly revising what we have done in the previous week. Startup command, the very first thing is instant starter. So what is happening here? Now see, you can see it is telling variable size, database buffer, redo buffer. It's telling a lot of things, but we don't know anything at the moment. And it is talking about some bytes and memory areas like that. So we are going to understand these things a little bit detailed. That's what we are going to start now. Great. So the very first thing is this. Oracle database server. A definition has been given. What is there? An Oracle database server consists of at least one database instance and one database instance and one database. Okay. An Oracle database consists of at least one database instance and one database. That is correct. Because in Oracle, one database always deals with one instance, one-to-one relationship. In a standalone environment, one database always deals with one instance. That means if I just show it practically, now here my database name is what? TNSDB. You can see my DB name TNSDB. And there's another name called instance name. Hope you noted, instance name. Now, this particular TNS19DB always deals with TNS19DB instance. So one database, one instance, one-to-one relationship. In a standalone environment, a single database will not deal with multiple instances. That is the theory. Standalone environment. That means one database always will have one instance, one-to-one. There is a situation where there what is known as one-to-many. That is a clustered environment. I think somebody asked this question some time back. That means what? One database has many instances. That is a clustered environment. In Oracle, we are telling it as real application clusters. Real application clusters, shortly known as RAC. RAC is for HA. HA means high availability. We will understand those things later. But in our situation, we don't have any cluster, we don't have any high availability. We have a standalone environment. That means one database, one instance. So that is the very basic starting point. Yeah, as a beginner, we should learn that theory. One database always deals with one instance. Any questions? Yes.
The clustering mean is like Kubernetes clusters?
No, yeah, go ahead.
Similar?
Go ahead. Okay. No. Yeah, that's a very good question. Actually, it's good that you asked that one. Let me just tell you. Okay. Let me just tell you. I will briefly answer this question for the time being. But since you raised the question, you go ahead to the channel. In the channel, we have the DevOps portal. No? In the DevOps portal, here. In the DevOps portal, I have given introduction to Kubernetes architecture. Getting familiar with Kubernetes architecture. This one, Kubernetes architecture mid-senior, because this is not a beginner session. Doesn't matter. You all are okay. Just you are quite fit into there. Go and watch this one. in here, yeah, again, let me skip, right? Okay, right. Now in here, see the very first thing is under Kubernetes architecture. Yeah, I am just giving an introduction to clustering world, a generic introduction. Computer clusters. So I'm just giving the overall introduction. It goes around 45 minutes across multiple sessions. Now this session goes almost 30 minutes. That doesn't matter. So I am telling what is a computer cluster, what is a database cluster, and a Kubernetes cluster, and comparing these things. So just watch that one. It will really answer your question in great detail. But let me just brief you for the benefit of others and for the time being, we need to have understanding. No, it's like this. Now, Kubernetes cluster is a total different thing. Total different thing, because Kubernetes cluster, we are telling it as a container orchestration platform. Container orchestration platform, because its architecture is to orchestrate something called containers. Containers are nothing much, small applications. Small applications. So what is this? What is going to do as a orchestrator, when as per the demand from the external, as per the external demand, it's going to start a container, shut down a container, start a container, shut down a container, likewise. And when the workload increase, it can scale up, scale down, likewise. So it's totally, Kubernetes cluster is a totally a containerized platform. It is using a containerized architecture, Kubernetes cluster. Got it? That is Kubernetes. Whereas on the Oracle, it is a software cluster. It is a software cluster. It's not a hardware cluster, because we have hardware clusters as well. Oracle is a software cluster. That means it's enabling the clustering at application level for the database. It is not based on containerized architecture, because containerized architecture came around 2014, no, 2013-14 with Docker. So Oracle was there before that. I mean, Oracle has been there in 1977. They introduced real application clusters around 2002, 2003. RAC came in 2003. So containerized architecture came well after that, after 10 years around that. So these two are different clustering levels. But of course, if somebody wants, we can embed the Oracle database within the Kubernetes cluster. That's true. That is possible. Because in the Kubernetes cluster, we have master node and slave nodes are there separately. So within a slave node, within a container, if you want as an image, we can embed the Oracle database. That is true. But it's not a recommended way of managing the Oracle database. There's a different way to integrate this Kubernetes cluster and Oracle database. We can talk it later. But for the time being, just try to understand in the clustering world, we have hardware clusters, we have software clusters, we have with Kubernetes the containerized clusters. So Kubernetes is a containerized cluster. Oracle RAC is a software level cluster. We have IBM, things like that. There are clusters which enable clusters with hardware at server level, at this level. Is it okay? Clear? That's a call.
Yes, sir. Thank you, sir. So එතකොට මේ software clusters එකකින් හදන එකෙන් බලාපොරොත්තු වෙන්නේ එතකොට අර database එකේ copy හදන එක වගේ එකක්ද?
Yeah, the whole objective in whatever cluster is to enable high availability.
Okay.
High availability. High availability කියන්නේ මොකක්ද? Downtime නවත්ත ගන්න එක. Downtime. That is what. Because that's why Oracle is a zero downtime, zero data loss database at any given point. Zero downtime, zero data loss. Down වෙන්නේ නැහැ. Down කරන්න බෑ. Down වෙන්නේ නැහැ කියන්නේ what do you mean by that? When a client wants a service from the database, it is always available. Now, when you go to a shop, when you want to purchase something, high availability, right? But in Oracle, it never says no. It says yes, yes. But it's up to us. It's up to the administrator to configure Oracle database in such a way to guarantee high availability. Oracle has features like basic high availability, advanced high availability, maximum availability architecture. A cluster is one thing. It has data guard, it has multiple standby sites, lot of things are there. But so primary purpose of any cluster is to give high availability. There comes scalability, scaling up, scaling down, those things are coming later. I mean, failover, automatic failover, manual failover, real application, failover, those things are coming later. Got it?
Excuse me, sir. ඇත්තටම බලුවොත් ඔරගල්ලාගේ high availability තියෙනවා ඒගොල්ලන්ගේ pricing උත් හොඳයි. ඇයි ඒ වුණාට තාම AWS Azure number 1 number 2 වගේ ඉඳලා Oracle place එක අඩුවෙන් ඉන්නේ?
Great. ඒ කියන්නේ ඔයගොල්ලෝ තාම standard industry එකට එනවනේ. එතකොට ඔය question එනවන්න. That's true. Let me answer. It's like this. Now AWS was the pioneer. Pioneer means they were the one who started this cloud business way back. Way back means actually they were a book company, not book selling company. Amazon library, Amazon website, they were primarily selling books, right? So after that, what happened in around 2004, 2005, they started this cloud business. So they were the first to start this cloud business. Remote web hosting, they started this cloud thing. So they were the first. So as a result, they captured a larger portion of the market segment. That's what happened initially. Got it? There comes Azure. After that, there comes Google. After that, around 2010, there comes Oracle. See now. So when Oracle entered to cloud business, 2010. So now we are talking about 12 years after, let's say 11 years after. So AWS, they has a history of more than 20 years, 2 decades. Oracle has only 1 decade history. So that's a very first reason. So at the moment, Oracle is coming up in a rapid pace. Now that's why they are secured their place overall in 4th and 5th position, actually 4th position overall. So this is within 10 years. Google and them, they started before Oracle. That's the reason. One major reason. Got it? So very soon Oracle will capture those things. And I think again, I have given a very brief explanation. If you watch this one again in the channel, I don't need to repeat everything here in the channel. Just watch this one. I think I have given that one for you. In the new series, I'm not sure did anyone watch that one. In the playlist under this new series 2021 Q1. In here, I think lesson number 3, I have given introduction for that. Just go through it and watch that one. So you can get the whole idea, whole picture. Okay, now other cloud vendors, Azure is catching up. So now Amazon has only, I think they are having only 50% of the market segment, whereas Azure is having 30% of the entire market segment. So they are, I think the gap is bridging now gradually. And again, people are preparing Azure as most preferred cloud to learn. Oracle has unique features. They have autonomous cloud. No one else has autonomous cloud. And they guarantee the speed of the cloud at anywhere. Their latency. Latency is, I mean, very low compared to other cloud vendors. Latency, and for example, now let's say if you want to do a cloud business with AWS, definitely you have to select. Now, if you are doing from Sri Lanka, definitely you have to select from the closest place, closest region, India or Singapore. That is due to latency. Latency means the slowness of the network, because when you select a region far to you, slowness is very low. But with Oracle, the latency is very low. That is their, I mean, the way that they are availability zone, landings. I mean, you have this the way regions, the availability zone, high availability zone, the way they have designed their architecture and the networking and all, due to that latency is very low in Oracle Cloud. Got it? So that's the answer, short answer. Idea covered. Okay, the question Harid. So in short, Oracle entered cloud business very late. That's the reason, main reason. Hello. I know the am I audible?
Yes, sir, you are audible.
Okay, I think something went wrong in this room. So okay. Okay, so got the answer, no? That's okay, right? Yeah. So any more questions like that? it's good that you are asking those things. You have to clear whatever. I will answer as far as I can. Anything I'm not capable, I just let you know later. But I think can manage because yes, because you can answer the questions in enterprise level as per your understanding. Now, for example, let's say if I have the knowledge only in Oracle, I won't be able to cover up the rest of Windows. But in my case, I have the enterprise grade knowledge. So therefore, across end to end, I can answer. So that's okay. But I am focusing here with the subject Oracle. But if the questions are coming, I am ready to divert to the other areas and link it up. So you can take the benefit of it. Great.
Excuse me, sir.
Yeah.
Sir, අර දැන් අපිට කලින් කිව්වේ AWS ගන්නවා නම් ළඟම region එක ඉන්දියා කියලා. එතකොට දැන් Oracle වලත් එහෙමමද නැත්නම්?
No, මෙහෙමයි. Oracle, we have Singapore, India also there. That's true. Oracle doesn't put a restriction like that. අපි මෙහෙමයි ස්ටෑන්ඩඩ් එකක් ගත්තාම හැම වෙලාවෙම හොඳ ළඟම region එක ගන්න එක තමයි. That is understood no. Latency එක අඩුයි. තේරුණා?
ඔව් sir.
Yeah, but if you get a region availability zone from Philippines, and if you get a availability zone from Philippines in AWS, in comparatively, Oracle latency is aduyi than AWS and Azure both. That's what I was telling.
I get the idea.
I mean the design, the way they have designed the cloud infrastructure. හේතු ඒකයි. මොකද ඒගොල්ලන්ගේ අර compartment concept එකක් තියෙනවා. where AWS and Azure doesn't have those things. Okay, right. පොඩ්ඩක් මම ඔය cloud පැත්තට පයින්නවා මේක මේ අපි ඉවර කරලා දාමු. So I jump that. Let's finish this area. Anyway, you can ask questions, right? So that is the starting point here, and now you got the idea. One database, one instance. Got it. Now we have database server. This is the explanation for that, which I just explained theoretically. Again, the graphic says database server is there, Oracle instance is there, and we have the database. Because Oracle instance is what is a logical component. Logical. Memory architecture. This is not something physically available. When we start the database, only this component comes in. But the latter part, the physical part, which is, I mean, it is there. You can see this physical components are what? DBF files, control files, and log files. Windows when you go to Windows, if you say app, Oracle, Data, I am in this for 19.3. What is this? This is physical structure. This is the physical structure. You can take DBF file, control file, log file. In Oracle database, physical structure consists of mainly what? 3 file types. What are those? Control files, log files, and DBF files. DBF files will maintain the data. Log files will maintain something called changes to the records that you are making with the transaction, especially with the DML commands. Control file will maintain the control information. We'll see more detail later. Control file will maintain the control information, what is happening in the database. Log files will capture the changes because of the transactions, especially the DML commands. DBF file will maintain the data, tables and nodes. So this is the physical architecture. We can see this. Logical architecture, can you see? We can't see because this is logical. That's what it says, logical. But Oracle logical architecture mainly consists of database instance, and within the instance we have something called system global area, SGA, system global area, and plus something called background processes. So Oracle database instance mainly has 2 components. What are the components? System global area and the background processes. Other than that, we have something called a server process. The server process is responsible when somebody want to connect external. Let's say user want to connect to the database. So how? Okay, now let's say you want to connect. Now this one. Now I'm going to connect here. Now here I have already connected. Now this is I'm exiting, clearing. Now I want to connect. Now whom as whom? Sys as this TBA. Now in this case, sorry, in this case, my database is in my local machine. Database is in my local machine, and I am connecting from that machine itself. So my client and the server are both in the same machine. But that's okay. Still I am connecting as a user. So to establish this connection, I am using a tool called SQL Plus. So what is SQL Plus? SQL Plus is my client tool. So I am using a client tool and giving a username and a password. Now this Oracle can't just connect like that. No. When I type the username, it needs to check whether such a user exists. Now sys is always there. Let's say I am using a different user. So that user must be there in the database. And the password, just to verify that password. So those verification has to happen. Now those verification, it can't just do those things. So there are processes which is in the background which is helping to do those verifications. So this is my tool SQL Plus, and if I go back here, so my client process starts at my where? On my client machine. In this case, in the same machine. In my case, because my client also here, no. So that is known as the client process. In the client process, I'm just typing username and the password. Then what's going to happen? That username and password will be sent to the database side. So from the database side, to acknowledge that username and password, there's something called server process is starting. So that's what very briefly we'll just try to understand. Server process is the one which is receiving whatever the information to connect the external user to the database. That is the process. It will receive the information from external request. Request means who want to connect to the Oracle database. That's right. Now, see, so what are the major things now? We have Oracle database server. Oracle database server mainly consists of logical component called database instance and a physical area called Oracle database. Now, I mentioned earlier, Oracle physical area, we have DBF file, we have control files, we have log files. Logical area, we have mainly two components, system global area, which is shortly known as SGA, and some background processes. These are the two main things. In addition to that, we have something called server process and externally user process. This is mainly to establish the connection from the external users. Clear? Got it? Very basic.
සයිතට මේ ඉන්ස්ටන්ස් කියන එක සයිතට මර අපි දැන් අර අර මොකක් ප්‍රෝග්‍රෑම් එකක් රන් වෙනකොට රන් වෙන ඒ RAM එක ලෝඩ්ලා රන් වෙන එක වගේමද?
ඔව් එහෙම තමයි. දැන් ඔයාගේ database එකේ give me a second. Yeah. Right, sorry. So when we start the Oracle database in our machine, it is start instance. That's what happening here. මෙතන අපි දැක්කනේ මෙතන starting the instance. දැන් මේක තමයි අපි explain කරන්නේ. This is what we are explaining. So starting the Oracle instance means it should start system global area and this background process on the server side. හරි, server side එකේ පටන් ගන්න. තේරුණාද?
හරි සර්.
Okay. Then when you want to connect to this particular instance from a remote machine or even in the same machine but in production environment, now why we are connecting locally to do the database administration part? No, because administrators connect directly to the server from that place or not. I mean from the same machine they can connect, even remotely we can, but normally the end users are not connecting into the server from the same place. No, they are coming remotely from using whatever application. Now in my case I just mentioned one application called SQL Plus, but there are many. Now I can tell you another one. I think last day also we had a look at on this. previous week. We have a tool called, let's say, SQL developer. This one, SQL developer. SQL developer, I'm not sure whether you are using this one, you are familiar. Now, if I start SQL developer, I think this is another graphical tool. Now, using this tool, I can connect to Oracle database. Now, this is a developer tool, database administration tool, both. We can do DBA, database administration of Oracle database using this tool, as well as we can write programs to Oracle database, select queries, or we can write PLSQL queries, programs to Oracle database. Now, these things may be used by developers. So, there are a lot of tools like this in Oracle database to interact with the database. Sorry? And these are just, this is again Java-based console, no? IDE, integrated environment. No? We have web consoles, graphical, I mean, from directly from a URL, I can connect to Oracle database. There are, that is known as Oracle Cloud Control. We have those utilities to do the administration in Oracle database. I will show you those things later. So these are very basic tools. We have advanced tools to manage Oracle database in production environment. Okay, got it? Right. So that is what instance, and we have physically database. So this is the phase one of understanding that. Now, what did we understood here? We understood Oracle database consists of mainly instance and a physical database component. Oracle instance, we have memory structures and a system global area. And the physical components, we have DBF files, control files, and log files. So that's all. If we, I mean, if we want, we can forget the server process and user process. That's okay. We will come back to it later. Clear? Shall we move forward? Okay. Now, yeah, program global area PGS. I will come back and explain it later. So we just try to get familiar with the basic stuff. Okay, now when it comes to the memory structure, basic memory structure, now I just mentioned system global area, SGA. Oracle lage thawa tiyena. We have program global area and user global area as well. It is there. But I'm not going to explain those things in more detail now. Now, these are the background processes we have. And we have, I mean, the process architecture. Now, in process architecture, I just mentioned only the background process and the server process, the client process. Within process architecture, I mean, client process and the server process. But for the time being, we focus on this background processes and the system global area. So let's try to understand the most important components initially, system global area and the background process. Okay. Now let's try to understand slowly what's happening step by step. Step one, we know what is the very first step. Instance started. Now that we know, we saw that practically. Now what's happening within the instance started? The very first thing is there is a component called system global area going to get started, SGA. So SGA consists of memory structure. That's why within bracket MMS. MMS means memory structures. Now if I go further, instance we just learned consists of background processes. Background process. And further, PG also comes in, program global area. Let's keep it for the time being. Now, if you go back to the SGA again, now SGA is what? It is a component which comes up when the instance starts. Now, within the SGA, I mentioned what are the things we have memory structures. So what are memory structures? The very first thing is shared pool. Shared pool. Now, here, now we are learning this one, right? I think it is clear. The first one, instance started. So here it says something. You can see it is using some terminologies: redo buffers, database buffers, variable size, fixed size. What are these? These all are memory structures. We are trying to understand what are those in detail. Now it doesn't show you shared pool here, but it shows you database buffers and redo log buffer. Even in this explanation, if I go further, the very first component is shared pool. And the second component is database buffer cache. You show that even in practically, you saw it here. We have database buffers, memory, one of the memory structures. Another one is redo buffers. So that we have in the theoretical explanation also, we have the same. You can see here, database buffer, keep that one for the time being, and we have redo log buffer, mainly redo log buffer. And further we have fixed and all, and we have more memory structures, And another next important one is large pool. But don't worry, we don't need to focus on everything initially. So our focus should be what? Oracle instance consists of memory structures. And the main memory structure, what are the main memory structures? Shared pool, redo log buffer, and large pool. Those are the main three memory structures. Shared pool, redo log buffer, and large pool. For the time being, don't worry about this fixed HTA, Java pool, Eva, then Hadisya Gandepa. Let's leave it as it is. So, but mainly try to understand shared pool, database buffer cache, and large pool. Any questions? Got it. Very important to understand this. If someone is trying to establish a career with Oracle stuff, and database is a must in that career, whatever career, and these things is a must. Anyone need to understand whether you become a developer or whatever, cloud support or whatever, cloud engineer, DevOps engineer, whoever it is, these are basics. Got it? Right. So don't worry about the rest of it. In memory area, just get it shared pool, redo log buffer, database buffer cache, large pool. And what are the background processes? We have system monitor, process monitor, PMon, SMon, that is system monitor, process monitor, DB writer means database writer, and we have CKPT means checkpoint, and we have log writer, LGWR is log writer, and we have other things, process manager, and we have this is a listener registration process. Now these are mandatory, that's why I have mentioned. Starting from Oracle 19c database, these processes, background processes are mandatory. That is, those things must be up and running in order to Oracle database to function properly. Checkpoint, DB writer, process monitor, because failure of any of these background processes will cause Oracle instance to shut down. Database is down, especially log writer, checkpoint, and all. Process manager, listener registration may be not 100% mandatory, but pman, log writer, checkpoint, mandatory. Got it? Okay. Now we know step 1. What is step 1? Out of these 3 stages, now see, there are 3 steps. When you type the startup command, the very first thing is instant starter. Step 1. Now we learn this one a little bit detailed. There are other 2 steps to learn. Mount and open. What's happening in mount and open, we will learn. But now we know this one in little bit detail than earlier. Now you know what is happening in behind when you say instant starter. Very first thing is HTA, then the memory structure, shared pool, buffer cache, redo, and the large pool, then the background process, system monitor, process monitor, DB writer, log writer, and process manager, and listener registration. Any questions you can ask? Make a thorough view. I have. I think I will upload these things for your reference. Let me just show you that one as well. Yeah, Oracle portal. Yeah. We just went to the first tutorial. We have the second one. Getting familiar with Oracle. I think this CP2. This one, yeah. Now in this diagram, activity 2, I have explained the same thing in this way. Is it visible to you? Pay not?
Yes, sir.
Yeah. Now you can see a much simplified one. Components are but both are same actually. So now you can see instance logical architecture. It consists of shared pool. Shared pool has two areas, library and data dictionary cache, but that's okay. Shared pool, database buffer cache, video log buffer. Make one large pool because large pool is not a compulsory one, it's optional one. But these three are compulsory. When we talk about Oracle database instance, in the SGA system global area, we have memory structures. Main three memory structures are shared pool, database buffer cache, video log buffer. Large pool is optional. And the background process, mandatory background process. Now here I haven't indicated that process manager and listen registration, those things I haven't put it here because this is a more simplified view, but those things are mandatory. I have mentioned here the most important three: DB writer, checkpoint, and log writer. More simplified one. And then down we have the physical structure: data file, control file, and its log file. Now for the previous batches in the assignment, I gave this question to draw a small simplified picture and explain these things, how it works. So therefore you need to understand these things well. Any questions you can ask? Okay. So let's jump to the step 2 now. Now we got to know step 1. Now don't worry, I'm not expecting you to draw something like this, right? Whatever you are learning, if you can at least come up with something like this, the previous one, this one, that is much enough. This is much more enough from your side. But this is at least this level you should know now, by now. Okay. So step number 1 is done. Instant starter. What is the second one? What is the second one? I think I have given the definitions for this instance and collection of memory structures, shared pool. Component introduce karla tiyenne, but api echchara vistara durata yanna ඕනේ නැහැ. Let's go to the second one. What is the second one? Second one is we should be mounted, no, database mounted. This is step number 2. Startup command. Step number 2. Database mounted. And mount this is what happens. This is where I am trying to explain this one now. Second step. Now this one we understood now up to here. Second step, database mounted. Now what's going to happen in mount? It is explained here. Just watch carefully. Now we know the database instance is up and running. May component idea this appears. What is this? I think you can tell me now. Physical structure, logical structure,
Physical structure.
Got it. Physical structure. So physical structure, we mentioned there are 3 types: DBF file, control file, redo log file. So out of the 3, when you're mounting, what's going to happen? The first physical file is going to come into the picture. Control file again, and it's going to get linked with instance. So mounting means what? Very simple thing is happening, and the most critical thing, very simple but most critical. When it mounts, what's going to happen? Instance gets linked with control file. That means control file will get open for read write. Control file. Control file will get open. So that is what we mean by mounting. Step number 2. Because without mounting, it cannot continue to open. Because to continue to open, Oracle should know where are the DBF files, where are the log files. Now those information are there in the control file. The location of the database files, the path, the size, name, everything. Current status of the DBF files and current status of the log files, everything is there in the control file. So therefore, without opening the control file, it cannot proceed to open. So that's why second step is mount, open the control file, get to know where are the rest of the DBF files, rest of the physical structure. That means rest of the log files and DBF files, locate them and continue to open. Continue to open. This is what's going to happen. Now, when it is opening, you can see data file came up, redo file came up, linked with the instance. Pretty simple. And the whole database is forming, and that is step number 3, opened. So if I revise it, what's going to happen? Now we have the control file. When it's opening, locate the data file as per the information given in the control file. Right? Here is only, this is an example. So locate the database files and locate the redo log files. Redo log files, minimum we have 3. Minimum 3. We can have more. And open them. That means link it up with the database instance. And that will form the physical part of the Oracle database. And now that will complete the open process. That is, third step is completed. So that completes the database open process. Now we have the whole picture here from the instance starting place. This is what is happening in the background. What is any questions you can ask?
Sir, why do we have too much aware about this process?
This the whole process.
Yes, sir.
So why? That's a very good question. Yeah. Why do you have to aware? Because now let's say, okay, now let's say you are working in a production environment, right? Let's say you are working in a production environment. Now, a user is a regular user. In the morning, every time he is running a query just to get a daily report. Now you are the, let's say you are playing the database administration role for that particular database. Let's say you are playing a DBA role. It's okay. I'm just focusing on DBA role, database administration role. Now suddenly today in the morning, the report normally comes in 1 minute. Suddenly the report is taking more than 5-10 minutes. Still the report is not done. After 12 minutes, report is coming out. And for the second time also, on the other day also, same thing happened. Now this is a problem, no? Because daily report usually it used to run within 1 minute. Okay, now what's going to happen? User raise a ticket. DBA. There's an issue like this, so I need your help to identify this thing. Right. Now, as a database administrator, you need to troubleshoot this problem, no? Right? Now, how do you troubleshoot? Now, for you to troubleshoot, you can't be just going on the query and identify the query was the same query, no? Right? The same query has been working, so there is no issue in the query. It's the same query, no change in the query, no? The query issue is not. Like you don't troubleshoot in the back end. There's something wrong in the database. Something has gone wrong. We don't know. We need to fix it. We need to troubleshoot. We need to look at the log files. And especially, we need to backtrace the issue. We need to identify each component of the database. Now, that for a particular query to get the output, okay, let's say that query is select employee number, name, order by, group by, where, and likewise there's a link as well. Let's say it's joining 2 to 3 tables. Likewise, it's a query with 10 to 15 lines. Let's say small query, 10 to 15 lines is a very small query. Got it? Now, to get the output, it does some process in the database, right? It does some process. Now, to get that step-by-step process, to link that to database, if you don't know these components behind the database, how are you going to troubleshoot that one? That's a problem. Okay, now let's say you are going to look at the log file. Log file says there is database buffer cache is running out of issue. There's checkpoint not complete. Waiting for log switch. Right? Now, to understand those terminologies, if you don't know these components, what is happening behind, you won't be able to troubleshoot. You don't know inside behavior, internal behavior of that particular query just before giving the output. Then now.
Yes, sir, it's clear very well.
Yeah, because you need to get the building blocks. Without knowing the building blocks, you cannot fix the permanent resolution. You may put a patchwork. Again, work around work around but that is a temporary solution. After 1 week, again the user gets starting complaining, no, it's not going to work, it's just a temporary fix. You need to give a fix for the problem or a resolution, which is a permanent solution. To do that, you need to have the expert knowledge. Right? Now, if you don't know this one, well, let's say you know this, you know this one, right? Now you know to start the database. Start with mount, open, you know something to do with this alert file. Now on right hand side, I have the alert file. Alert file is the, I mentioned this one actually. Alert file is the Oracle main log file. I know about that one as well. I can just temporarily maybe I mean, based on assumption, I am giving that. So that is not an expert solution. It is a what? It is a all-rounder solution. All-rounder solution. So who is all-rounder? All-rounder is a person who just knows everything from outside. Or surface level he knows, but he doesn't know what is happening inside. Building blocks he doesn't know. The person who knows the building blocks, who is that? He's an expert. So in a production environment, when a critical problem comes in a project environment or production environment, we don't take the input from all rounders because those are going to just temporarily fix the problem, but long term, again, it will come back. So that's why to get the expert knowledge, we need to know the ins and outs, what's going to happen. Got it? Right. ඒක හොඳයි ප්‍රශ්න අහපු එක ඇත්තටම දැනගන්න බැයි මේ මෙච්චර මේ නටා ගන්න කියන්නේ to understand. That's very good that you asked that. Okay. Now, not only in Oracle database, even if you're learning cloud, now the cloud architecture, very fundamental. I mean, you need to thoroughly know that. Availability zones, disk group, distribution, primary zone, secondary zone. You need to know this. VPNs, how to interconnect, how to share, everything you need to know. Scope එක ඇතුළේ දැනගන්න ඕනේ. මේ අපිට හැමදේම දැනගන්න බෑ. We need, there is a scope, no, there's a role that we are playing. Now, if you are a developer, you don't need to know the deep dive. But at least this basic understanding, you need to know. But if you are a database administrator, in cloud, if you are a cloud architect, you need to know entire, I mean, let's say to have a high availability zone with resiliency and all, to have a cloud design, you need to know the architecture with this level as well, with network level as well, storage level, like a process level, instance level, you need to know those things, depending on your job role. Got it, no? So any questions you can ask, yeah. Clear, no? Right, okay, fine. Let's proceed now that you know now instance starting and okay. Right, so let's not go into more detail. Now, why my primary purpose is to give you idea about this one. Phase 1 you got to know. Now we know what is the startup and the steps in detail. Okay. Let's have something like this. Now, let's say, okay, even if you go back to this document, we have the practicals as well, hands-on, yeah, Oracle database shutdown process, and okay, let's try to learn those things as well. Now, let's say I'm going to shut down a board. Down. Then මෙහෙම කරනවා. Startup එකක් ගහනවා. ගහනකොට mount වෙන්නේ නැහැ. Suddenly it gives an error. It is not mounting. How are you going to troubleshoot that? Mount වෙන්නේ නැහැ. Due to some reason, due to a maintenance issue, you just shut down the database. As a database administrator, you have shut it down due to a maintenance issue. Now you are going to start it up. It's instantly starting at mount is giving an error. Unable to mount. Then කොහොමද කරන්නේ? මොකද්ද කරන්නේ? කාටද කියන්න පුළුවන්? මොකද්ද දැන් mount වෙන්න නැති වෙන්න හේතුව අපි දන්නවද නැද්ද දැන්? Do we know the reason why it's not mounting? From the knowledge that you learn up to now, can you tell me what's the reason why it's not mounting now? කියන්න බෑ. ඇයි mount වෙන්නේ නැත්තේ දැන් ඉගෙන ගත්තට කියන්න. I need to go back and link here what is happening at mounting. මොකක්ද වෙන්නේ mount එකේදී? මතකයිනේ what happening at mounting? Control file getting open. Now if it is not mounting, that means what has happened? මොකක් වෙන්න පුළුවන්? Yeah.
background process running නැතු
ඒක හරි. හැබැයි දැන් මේව දැන් mount වෙන්න ඕනේ control file එකනේ mount වෙන්න ඕනේ. If it is not mounting, primary reason is what? Control file is missing. You can mount it. Now to mount, what is the fundamental requirement? Background process වෙන්නේ මොකටද? Background processes are required for instance restart, right? Body. So at instant start, memory structures and background process started. That we learn. Now the instance is started. That's what I mentioned. Instance එක අප් වෙලා තියෙන්නේ. Now the mounting is not happening. The mounting has nothing to do with the background process at the moment because background process up and running. Control file එක නැත. That's why it's not mounting. See, now to get that idea, මේ පිටිපස්සේ වෙන දේ ගන්න නැත්නම් ඔක හොයාගන්න බෑනේ ඔයගොල්ලන්ට. You can't. That's why we need to understand the process what's happening. Now, because now there is a maintenance, there is a downtime. Downtime now let's say for example in a production environment, to do a monthly maintenance activity. Monthly maintenance activity, we have a downtime window. Downtime window means we getting a pre-approved time frame. End users are not working. 6 hours downtime window is given to maintenance activity. Now all the maintenance activity is done. Now at 4:30 we are trying to start the database. Now suddenly mount වෙන්නේ because 6 hour window is 6 hours. By 6 AM in the morning, we need to start the database and we should give it to the production back to for them to continue their business. End user online user and business is down. Business is down means their profits and money, everything is not coming. Business is down. Right? So we can't let that thing happen. No. So we need to troubleshoot. Now why is not mounting? Control file is missing. That's why. So that is one of the reasons. That's why I mentioned we need to understand why is not mounting. Control file. Main thing is control file. So we need to either find out a copy of the control file or we need to get a backup of the control file and restore and do a recovery and try to mount it. Recovery process can be if it is we don't know whether the display has happened or something else, control file logical corruption has happened. We don't know the reason. But anyway, we need to get a backup and restore it and mount the database. It's a critical thing. Control file losing control file is critical thing. Now to avoid that only in Oracle database, we have multiple control files. If you look at this one, our ඔයගොල්ලන්ගේ instruction තියෙනවා බලන්න in app Oracle, how many control files we are having? CTM file දෙකක් තියෙනවා. File දෙකක්. This is known as theory of multiplexing. Theory of multiplexing. Multiplexing theory. Multiplexing is one of the features in basic high availability. Basic high availability. Right. So what is multiplexing? Distributing multiple copies of the same file, multiple copies of the same file. Now in this case, our control file, same file to different dislocations. Multiplexing is that distributing multiple copies of the same file to different dislocations. May dislocations has to be physical dislocations. Physical disk. Just because you partition the single disk and you are going to have C drive, D drive, E drive, and you are going to keep one control file in D drive, another control file in E drive, that is not multiplexing. We need to have physical disk. To get physical disk, we have systems. So, we have RAID systems, but let's not go into that detail. And Oracle has ASM as well, automatic storage management, those features are there. But multiplexing is that. Now, in case of multiplexing, let's say we have two control files, two CTL files. One is in, let's say, this one, this one, this two. We have this two. Got it? Now, even if this one is crashed, we have the other file because it is a different disk. Whereas if you keep both files in the same disk, if the disk crash, both are gone. So no point of keeping two copies. If you keep in two copies, we need to multiplex it, distributing across multiple physical disk units. So this, yeah, go ahead.
So in our computer, we both files are in same drive. So how can we manage that to another drive?
Yeah, that's right. Now these are learning environments, no? So for learning environment, it is okay. This is I'm talking about in production environment and business industry. We don't do those things. Now, if you want to do it, now we can't. Now even in my machine, see, I have two partitions. Partition if you go C and D, this is I have only one T disk partition. So that is not the same disk. Then I need to have another physical disk unit. Okay. So but in learning environment, it is fine. But I am telling in production environment, we don't do that. We have to multiplex. Got it? So that is Oracle basic high availability. High availability advanced, we discuss clustering, data guard, idea. But this is very basic high availability for a standalone database. Then the idea is it okay?
Okay, sir. Okay.
Okay. So that is what. That's the first thing. Control file then okay. Now let's say for example, now that happened. Startup instance you are starting up. So what happened? Your instance started. Now our situation was unable to mount. And the situation unable to mount. So that is why the CTL file is missing. Now we said take a backup. Okay. Now it's get mounted. Then the next step is what? Opening. No. Now what's happening during open? Open open. Open the DBF files as described in control file. That's what's going to happen. Now that step fails. Open fail. Now these are the things that can happen in production environment due to various reasons. If we have followed the best practices with Oracle database, if we have designed the database nicely with high availability, it won't happen. But our DBAs, our architects, they don't do those things. Always they don't follow the best practices. No? They are trying to experiment with their own architectures. So in production, we can't be learners in production environment. In production environment, we have to be experts In learning environment, you have to do the learning. In production environment, we are going to add the value to the organization. If you are a learner, then that's a problem. That means you are doing your experiments with the production. That is not acceptable. Whatever experiments, we have to do the testing environment. So in testing environment, you have to do this hands-on and learn. Then you should be ready to deal with production issues. That's all. If you are a very good expert, actually with Oracle database, you don't have issues. So due to the lack of knowledge only, there are issues coming in. So that's why if you learn the architecture well, and if you have very high knowledge, then nicely you can very smoothly you can handle the Oracle database with very minimum issues actually. That's what that is what needs to happen. Okay, open pairs. What are the reasons? Now you have to tell me. I database open and nasty. Now we just learn few points. Yeah, why it is not open?
Excuse me, sir.
Yeah.
database එකෙන් data ඒ කියන්නේ අපේ ගාන database කීපයක් තියෙනවා ඒකට අදාළ control file වෙනවද නේද?
Yes. This is I mentioned. This is one database, one instance. Now this is per database. Per database there is a control file. One minimum 2 control files. Right. If there's another database, ඒකට මේ වගේ separate structure එක වෙනම තියෙනවා. තේරුණා? Now very simple.
Yes,
මගේ machine එකේ database දෙකක් තියෙනවා මේදී. I have ORCL is one database. So this is for that one. Control file, log file machine. It is for that. This is another database. ඒකට මේ ටික. ඉතින් වෙන. Got it?
Yes.
Now when I start ORCL1, that instance will get start. And it will deal with these control files. If I start this one, that instance will start and it will deal with this control file. That is what going to happen. But in production, in a single hardware machine, in a single box, we don't run multiple databases. That is not recommended. We don't do that. With Oracle, we don't need to run multiple databases. I mean, it allows a different architecture for us. For many applications, it allows something called schemas. We will learn it later. Schema. So a schema can run a different application depending on our requirement. Now, let's say if you are an organization, you may need to do accounting, you may do sales, you may do production. Category, let's say if that organization is a manufacturing organization, production, supply chain, you have accounts department, you have loan department, and okay, there are a lot of applications, right? So, I mean, the account department have their own applications, supply chain has their own applications, manufacturing, raw material, there's another application. Now, for each application in Oracle database, single database can have different schemas. The schema is set of tables and objects, indexes, views, belongs to a user. We will learn it more detail later. So, therefore, in Oracle database, per application, we don't need to have separate databases. That we don't do. It's a large database. In a given machine, with a single database, we can manage many applications. Got it?
Yes.
Okay, right, good. Fine. So my question was, yeah, why is not open? Try Canva. Yeah.
File may be damaged.
Exactly. Which file out of 3?
Control file, I think.
Then open.
Then data file.
Exactly. Either data files, one of the data files, or redo files, damage, access now, crash, corruption, we don't know, or maybe deleted, we don't know. Something has happened. So due to some reason, open can't be. Because at open, Oracle checks for the availability of the old data files and redo files. Open negative balanoya. Because it needs something called a synchronization. Sync up window. Sync up. What do you mean by sync up? Control file says it is aware of, it has 15 dB files. Control file like data file and 6 redo log files. So therefore, Oracle will try to get all of those 15 dB files and the 6 redo log file. So if those at least one of the DBF files not available out of 15, it raises error telling I can't access this. Control file says it is available, but I can't find, so therefore I can't proceed to open. So we can put the file into a mode called offline. ඒක ගැන worry වෙන්න එපා කියලා Oracle ට කියන්න පුළුවන්. We can tell as administrator, don't look at this file, but open the rest of the 13 files. We can tell that. But initially, it will look for that file. Now, look at that. To troubleshoot those information, if you don't know that architecture, we don't know what's happening. What is instance, what is mounting, what is opening. Now, since we know what is happening behind, whenever there's error comes, we have a solution. Otherwise, more the time you take to solve the problem, more the business downtime, especially with Oracle database. So why production is running with Oracle database? Because they want a highly stable environment, because Oracle can cheap, Oracle is a database which has many features. So that's why organization expects you to make use of that particular features and to give that, high availability things. We don't need for the business to run smoothly. That's the expectation. So therefore, we need to make sure it is achieved. Expectation is the end one. Unit Oracle. Yeah.
So again, my database the file damage not open in.
That's why by default, I just took a situation. We can avoid that one actually. We can avoid that one. By default, that's the behavior. By default, that's the behavior. That's a good question. Let's say, production let's say there are 1000 DBF files. There is DBF rest of the 99,999 data DBF files are okay, but just because of one file is not going to open. So it's it's reasonable, no? So we can run database in a mode called archive log mode. Archive log mode. Then what it will do, it will keep that particular file away and it will allow the database to open. But by default, database is running in no archive log mode. So that's the thing. So it's up to the DBA to design these things properly. A best practices implement karan role.
Excuse me, sir.
Yeah.
So then archive log mode එකේදී දැන් අපි හිතමු මේ ෆයිල් 1000න් ෆයිල් 200ක් විතර අවුල් කියලා එහෙම වුණොත් මොකද වෙන්නේ?
Yes. Then there's another theory called in Oracle database. Now in standalone database, we have critical DBF files and non-critical DBF files. Critical DBF files and non-critical. So what are critical DBF files? Now we know the system DBF file. System DBF file. And we have undo DBF file. Here we have system. Here we have system within system. And we have undo. Now these are critical DBF files. So if no damage has happened to those critical files, no problem. We can keep them away. Remaining, that's our preference, right? Our preference, because there are other issues by opening the database in that way. I'm not going to take it now at the moment. Let's clear this problem. So if it is not a critical DBF file, yes, we can open the database. But if it's a critical DBF file, it will not open under standalone circumstances. Standalone. A database high availability. What is? So those are the situations why we are not operating a database in production without having HA features. High availability features, database production. So if it is a production, at least we have to make sure. Okay, now to enable HA, we need real application clusters. hardware හැම යනවා. I mean we need to have some infrastructure cost there. I'm not talking about cloud. I'm talking about on-premise. ගොඩක් on-premise තියෙනවානේ ලංකාව ගත්තත්, foreign ගත්තත් still we have on-premise thing due to security, due to data confidentiality, cloud නොගියව තියෙනවා තමයි, right? So let's say we can't go for rack, then at least we need to look at SBY, standby එකක්වත් බලන්න වෙනවා. What is standby? In standby we have primary site, and we have standby site, SPY site. Now in such a situation, let's say due to some reason critical files has gone and we cannot open the primary site. Again, primary site එක down නම් එහෙනම් මොකද වෙන්නේ? We can do a failover to standby site. Okay. Metan operation දෙකක් තියෙනවා. We can either do a failover or we can do a switchover. Failover is automatic, switchover is a manual process. So then nicely, without having a downtime, we can let the business to run till this site comes up. That is possible. So that's why in production, at least we need to have a single standby site. Ek standby site එකක් තියෙනවා production.
So site එකේ ඇතුළට hard disk එකක් නැත්නම් server වෙනම.
No. Site is a physical site. Now let's say for example, okay, Sri Lanka, let's say, okay, data center එකක් තියෙනවා. හරි. අපි ගමුකෝ example DSI වගේ company, let's say DSI. DSI is a manufacturing company. They are අපි කියමු they have their head office. Head office තියෙනවා කියලා. Let's say Maharagama, they have head office at Maharagama. And here their primary site is at Maharagama, right? So primary DB site එක කියලා කියන්නේ ඒකයි. Physical location එක. Okay, physical geographical location is their site. Right? So that is in Maharagama. Now, in case of a failure, DSI have their secondary site replicated 100% syncing up always with the primary database. This one is at goal. This is their secondary site. Now, at any given point, these two sites are 100% synchronized. 100% synchronized. There's a Oracle, there's a feature called active data guard. What do you mean by 100% synchronized? If a user commit a record here, immediately that record will be available here. That's what synchronized means. If a change occurring here, that change will be transferred to the standby site immediately. Got it? So that means if an issue comes here, let's say at 10:30 a.m., primary down, this no issues, no. Here also 100% sync up to the 10:30 a.m. So what Oracle will do, it will automatically initiate a failover process. Because this failover down, so end user will disturb. So what Oracle will do, the ongoing transitions also, it will take it to this site automatically. It's Oracle powerful. If there are select commands, if there are update commands going on in the primary site, it will automatically seamlessly transfer standby. So at the end user, wait time depending on the speed of this network, there will be a fraction of seconds. Hangout. After that, its transition will continue as normal without a failure. That's the important thing. So this is not a basic HA environment. This is a level 2 HA environment with standby. Okay.
පොඩි ප්‍රශ්නයක් තියෙනවා සර්.
Yes.
සර් දැන් අපි හිතමු primary DB එක down වුණා. ඊට පස්සේ secondary එකට මාරු වුණා.
ඔව්.
මේ ඊට පස්සේ primary DB එක up කරගන්න තව පැය දෙක තුනක් හරි ඒ වගේ ප්‍රමාණයක් ගියා. එතකොට secondary එකේ data වෙනස් වෙලානේ තියෙන්නේ. එතකොට ආපු එක primary එකට එද්දි.
Yeah. That is switching back. Yeah. Let me explain that one as well. Those are good questions anyway. So අපි ඔකට කියනවා back and forth switchover and failover operations. Right. Now let's say this happened in 10:30, no? Now 10:30. Now let's say due to some recovery, the mega gear pair they got 2 PM mona. Let's say okay. Now it's a pair. So it's operating here. Now for that 4 hours, we are doing operations here, no? Operations here. Let's say 100% workload, 100%. Now these things are initial decisions, because before going on standby high availability, we need to come up with these things, and I will just tell you what is our RTO, recovery objective, and RPO, recovery time objective and recovery point objective. මම දැන් ඔක්කොම කියන්න යන්නේ නිකන් ඔයගොල්ලෝ මේවා නිකන් නෝට් කරගෙන පස්සේ හොයලා බලන්න. We need to come up with what is our recovery time objective and recovery point objective. It's like this. Now business need to confirm initially when a switchover happen to the standby side, whether are we expect to run the 100% workload that was running in the primary or not, or we need only a 50% workload. Those things are initial decisions that we have to make. So critical now 100% යන්න ඕනේ. So what I'm telling is this. Now when the organization is investing on a standby side, right? Now let's say if my primary database is a 2 terabyte 5 terabyte disk set එකක් තියෙනවා. ඊළඟට 198 cores, memory also let's say 300 GB RAM තියෙනවා. ගොඩාක් ලොකු processor එකක් කියලා කියන්නකො. Let's say it's a high performance machine. Now whether the organization want to have a same infrastructure on standby or not is their decision. If it is yes, that means that business is so critical. So then it's okay. That means we are expecting 100% load transfer. Load transfer when there's a failure happens to the primary side. So 100% load transfer. Let's say with that 4 hours operate kara. 4 hours operate kara. Now let me tell you, in Oracle, the feature active data guard, we need to understand what is the failure happened on primary. Now let's say the failure is a disk failure. Causing let's say 10 dbf files to damage. 10 dbf files to damage. Rest of the dbf files are fine, no issues. It's working. Out of 1000, the hack 10 dbf files are damaged. Now because of this, it went down and it switched over for this one. Now 4 hours has gone. That means this fellow is advanced than him in terms of time 4 hours. So those changes are not available here now. Now the very first thing is, how do we initiate recovery here? Won't make a recovery initiate. How do we initiate a recovery? Now I tell you the best and quickest method. With let's say even 19C, we have this. Yeah, this is okay. This way okay. So what we can do, either we can apply backups. So backups apply karaddi krama godak thiyena Oracle database වල. Whether we are going to use a tool called RMAN, recovery manager. I tell you the short method. Best method is what we can take the current files from where. Now standby site is operating, no? Standby site is operating. So what you can do, using recovery manager, there's a tool called recovery manager. The ongoing files, the files which are running at the moment, those things we can transfer to here initially. Because now those files are totally out. We can't have those things. It is damaged. So from the standby side, without taking the backups is a different thing. Now from the standby side, the ongoing files we can copy to here. That's the first thing we should do. Now rest of the files, what is the situation? The gap of 4 hours are there. තේරුණා මං කියන එක. දැන් අර ෆයිල් 10 සම්පූර්ණයෙන්ම ගිහිල්ලානේ. තේරුණා නැත්නම් කියන්න.
තේරුණා sir.
Yeah. Those 10 files be totally out. So we need to copy the files from the beginning. Let's say එක ෆයිල් එකක් 500 GB වෙන්න පුළුවන්, තව එකක් 300 GB වෙන්න පුළුවන්. ඔක්කොම network එක හරහා copy කරන්න. We need to copy those things. So it's a little bit crucial operation depending on the situation, but this is a short method what I am telling. So copy them, but rest of the files, what we have to do? We need to apply the 4 hours changes that has happened in the standby side. ඒක sync up කරන්න පුළුවන් RMAN වලින්. That is possible. Recovery sync up එකක් කරනවා අපි. So after doing everything, still අපි ඉස්සෙල්ලා මේක mount එකට ගේනවා. Mount එකට ගියලා open read only එකක් දාලා බලනවා වැඩේ වැඩද කියලා. open read only. වැඩ නම් මොකද කරන්නේ read write open කරනවා. We'll open in read write. So then we'll allow this way to happen. Now if database is open, so we'll allow it to work for a certain time. Sync up එක යන්න කියලා දෙලා මොකද අපතර then what we will do, we will do now what happened actually the failover එකක් නෙවෙයි, that is automatic one. No, failover is an automatic operation because it got to know that primary site is going off. What through active data guard, Oracle will automatically initiate the failover. ඒක DBA කරන්න ඕනේ automatic මෙහාට fail කරනවා. I mentioned that one earlier. Now since now primary site is back online, DBA come back and now he decide, okay, now is everything is fine. He will do something called a switch over operation. Switch over operation. Switch over operation back to old primary. Now our new primary is this. Make a new primary. This is the old primary. So now we have to revert the roles. Roles take a mark. Now this fellow is playing the standby role at the moment. This fellow is playing the primary role. As switch over role transition has happened now. Now we need to transit the role backward. Make this one to the original role, to the standby role, and make this one the primary role. So switch it back to that role. That also can be done. We are in Active Data Guard. We have interface ADG. What is that? A DGMGRL data guard manager. Via that we can just initiate the very few commands we can do, and it will take it back to normal. That is possible. Oracle is such a nice database. Make it critical na Oracle leke. Even though scenarios looks like big, but for experienced DBA, this is a basic kind of a thing. We can do it. But idea you got the idea?
Yes, I got the idea.
Yeah.
So තව පොඩි ප්‍රශ්නයක් තියෙනවා.
Yes.
So switch over එකදී එතකොට දැන් අර standby එකෙන් අරගෙන මේ main DB එකේ තියෙන file ටික ඔක්කොම replace කරනවද?
No, no, that's not going to happen. It will do a sync up, gap resolution එකක් කරන්නේ. ඒක දාන්න ගියොත් එහෙම පැය ගණනක් යනවා. ටෙරාබයිට් එකක් copy ගන්න ගියොත් that is a big problem no. Oracle will capture the changes, change capture කරන් gap එක කරන් gap resolution එකක් කරන්න. Oracle is so smart, it won't do that. Originally copy කරන්නේ මේ 10 මොකද ඒවා this is totally gone no. So we don't have answer for that. It has to copy. But the only plus point here is we don't restore a backup. Rather we copy from the ongoing operation. Redo make an standby can copy කරනවා මෙහාට. Backup එක දාන්න ටිකක් තව වෙලා යනවා. We don't do that. And the rest of the files it will sync up. Sync up means that it will gap resolution and it will balance only. It will get sync up.
So okay, එකම ෆයිල් එකේ copy හින්දා එක ෆයිල් එකක් විතරක්ද මෙහා එන්නේ?
මොකද?
ඒ කියන්නේ සර ෆයිල් 10ක් තියෙනින් දැන් අර මේ ඕකෙන් දැන් DBF ෆයිල් එකක් සින්ක් වුණාම ඇතිනේ සර්. ඒ කියන්නේ මේ එක ෆයිල් එකක් විතර transfer උද වෙන්නේ නැත්නම්
No. Our scenario was 10 DBF file has gone. මේ disk එකේ file 10ක් තියෙනවා ගම්ම. DBF file 10ක් තියෙනවා. ඒ 10ම basically crash වෙලා. So we need to get those 10 files from this standby and copy here. තේරුණා? ඒකයි මම කිව්වේ එතන.
විතරට මේ DBF ෆයිල් තුල same copy හින්දා 10ම transfer කරන්න ඕනේද?
No. Get it like this. Now these three files are 10 different files. A.dbf එකම file එක නෙමෙයි. B.dbf we have 10 different files. Are physically 10 different files. So we need to copy these files as separate data. තේරෙනවද? data වෙනම තියෙනවා. Okay, got it. අපි හිතමු file 1000ක් තියෙනවා නම් this is like 990 files are okay. 10 of the rest of the 10 files. The rest of the 990 files, it has to do the gap resolution and sync it up. Got it?
ඒ කියන්නේ සර් සම්පූර්ණ database එකේ සම්පූර්ණ data ටික වෙන වෙනම file වල තියෙන්න පුළුවන් නේද සර්? Copy
Yeah. Good questions. Yeah.
මම හිතුවේ සර් මේ එකම file එක ඒ කියන්නේ database එකේ තියෙන data ඔක්කොම එකම file එක තියෙන්නේ කියලා.
අපි ඒතව කතා කරේ නෑ. වෙන කවන්නේ. ඉන්න ප්‍රශ්නේ අපි ඉන්න මම ඔකට ටක් ගාලා කියන්නම්. I think it is important to tell it now because you get the full picture if I tell it now. Let me just show you that one. This is how that is known as Oracle. We have the logical and physical structure එකක් තියෙනවා. Logical structures and physical structures. Let me tell you that one as well. Then It helps you to understand. In the meantime, others questions I'm prepare karang in the hand. Not here, not here. It is here. Oracle portal. Yeah, this is this database architecture. I think this document. Okay. Oh yeah, we have it. Okay. Now this is the Oracle logical and physical hierarchy. This is something we need to understand. I'll tell you this in more detail later. In Oracle, the physical component, the database side control, redo DBF files. Now these DBF files are organized in another logical structure called table space. Table space. So within the table space only we have the DBF files. Each DBF file carries data, belongs to these tables, indexes, objects, database objects. So make a practical let's say I want to see describe DBA. Okay, hold on. Now make a down start up there. Okay, so describe table spaces. I want to see the table space name. I want to see what are the table spaces in my database. So I'm just typing select table space name from DBA table spaces. So these are my table space names. So I want to select the data file name. Select name from DBA underscore data underscore files. Hold on. Select name from. I can take it from VDOLA data file. To check the data files, I'll get it from VDOLA data file. මේක නැචර කලබල වෙන්න එපා මම දැන් මේ පස්සේ මම මේවා කියලා දෙන්නම් data file S එකක් නැහැ VDOLAs are not plural singular. Okay, now you can see the DBF file මම කොරේ එකක් ගහලා ගත්තේ earlier we saw it graphically browse කරලා ගත්තට කියනවා තමයි right. So this is in my current Linux database. Now for data file it belongs, data file must belong to a table space. Now, example like that. System sysocs. Now, system belongs to system 01 DBF belongs to system table space. Like that. Users data file belongs to users table space. Okay. So we can link it up here. Table space name, and we have, I think, data file name. Now, let's take it like this. Let me link it up. Describe DB underscore data underscore files. So we have this one. From here, I can get the select file name. Then graphically, but initially I am not using the GUIs because for you to get familiar, we need to use the command line initially. Later only we can go for GUI. We have the GUI in Oracle. DB data file. From this. See, table space system consists of this file, system DBF file. Table space users consist of this one. So given table space will have one or more DBF file. Now in this system, make a database in production, user DBF, users table space will have more DBF file, many DBF file. I did now thought because the idea again. So here we are told, that's why we are talking about many DBF files. Now these DBF files may belong to different table spaces as well, that we don't know. But our problem is not that. Our problem is just restoring the DBF files, which can to them. I mean, we need to minimize the data, we can't lose the data because within the DBF file we have records, tables, lot of things, data is there. Got it?
Sir, clear, sir.
Okay. Now this is a second level HA environment. We went in to discuss about standby sites and all. But I think then if the environment is so critical, if they are high availability, they want zero downtime, and I think make a thariyan, right? Because now here what is happening is switching over to a different site, no. So sometimes it might take time due to network problem. So that's why the next solution comes a real application cluster, rack solution. Now rack is not this way. Rack in the single site. Oracle has something called MAA. MAA means maximum availability architecture. I have some videos I'll show you later. In the maximum availability architecture, now the previous discussion was something called site failure. So I mentioned Maharagama primary site and the gold standby site. So that is failing from one primary site to standby site. The second MA architecture is server failure. What is server failure? Before failing to the site, it will manage the failure within the site, failing to another database server. Now, for example, let's say my primary site is a cluster. Rack real application cluster. It's a cluster. Okay. So if it is a cluster, I am going to have 1 DB, many instances. Instance 1, instance 2, instance 3. Instance 3. Right? Each instance is located in a different machine. Machine 1 again host computer server host 1, host 2, host 3. Host 3. Likewise. So each host is a server, physical machine. Got it? Now this is the primary site. The standby site, we have the standby site separately. Now in the standby site, it may or may not be a cluster. We don't know. I mean, it may be a standalone environment. It may be just a single standby server. That's okay. That's fine. But now what's happened? Due to some failure, make a crash or not. May server a crash or not. Now what will happen? Standby site yeah. That's right. So that's why server failure will take place. In a clustered environment, if this crashes, it will payload the next immediate available load the server less load. There are criteria, it will payload this one till this gets recovered. That's what. So in this scenario, it will payload the standby if whole site goes off only. Then the whole primary site has to go off. Then it will switch over to this one. So we can have a symmetric scenario. We can have the standby also cluster. That's not a problem. So either standby single server or cluster, that is okay. So that's the second HA, design we can have for maximum availability architecture. So it will first manage within the site. Depending on the requirement, it will switch over to the standby site.
So a cluster with load balancing,
Exactly. Load balancing, failover, switchover, application transfer and failover, cluster. Right. So this is the advanced environment than the previous environment. Got it? But you need to get this idea because how a database follow best practice. Again, the primary one of the primary purpose of Oracle database is to zero downtime, zero data loss. Oracle says it is a zero downtime, zero data loss environment. Their database, they guarantee that. So as the administrator, so as the end users, or the people who are designing the database, architecting the database, we need to know those best practices and how to implement those things. I mean, when a crash happens, if you are losing data and the business is going down, no point, no. And then after that, what's the point in world #1 database? So that's right. So we can continue the database design from a basic HA environment to advanced HA environment like this. Got it? Now this is zero downtime, zero data loss at any given opportunity. If you have the both environment clustered. Okay, any questions, any further questions? Tiranahan. Right. Okay, now I am not going to mama divert kara lesson එක මොකද මේක පස්සෙම අපි යන්නේ නැහැ, but whenever required I am linking to this. Now our next goal අපේ ඊළඟ target එක තියෙන්නේ we need to see how these components interact with each other. Components interacts. Components. ඒ කියන්නේ මෙන්න මෙහෙම එකක් තියෙනවා අපිට ඉගෙන ගන්න. මේකත් ටිකක් critical. මෙන්න මෙහෙම එකක්. See, I'll just show you a small graphic. When a user issue a command, when a user want to put a select hurry, update hurry, create hurry, whenever end user issue, let's say update command, how it is behaving in the backend. And we have to do a walkthrough across these components, linking all together. For example, from select to update to a commit to a rollback, how it works all together. A walkthrough. Then you will get a full picture of Oracle architecture and how it works nicely. The Marian explained diagram, but anyway, I'll do it for you from the beginning. That I will do. So next day, I think we have to take 1 hour around for that. I think if you can do that, that will be enough for you to the architecture. Architecture at your level, because now this is at university level, third year level, no. So that is more than enough for you to understand, and now you getting close to the production environment. So it is better. In addition to the you can ask me, and you feel like it's better we do this, and likewise, and having done that, I am going to switch to the Oracle Cloud and link it up with the on-premise and cloud sync up. So likewise, and let's see how well but I think we have only another 2 more days, if I'm not mistaken. Full days ITN. Let me try to make it 3, because we had only 8 sessions allocated, I guess. Yeah. All right, any questions you can ask for today? I'm not going to start it today because let's keep it for other day. But any questions on the explanations today, you can ask. Practicals practicals. We have many, so always try to start your database and all. Okay, so let's checkpoint architecture and those things I cover with other explanation. So any further information, you can refer to this architecture explanation. And this is almost at the end level. I think I have given 31 sessions. Yes, I mentioned that one earlier as well. So all are well explained, and learn slowly. So that is better. Okay, I think Yes, this one we'll do it on next day, and the tablespace architecture and all we'll do it on next day. After that, we'll go for cloud and basic tuning, and those things are there. All right. Right. So if there are no questions are there, then shall we finish it for today? Are we okay? Any questions you can ask? Great. No? Okay, then we'll end it up for today. Then next Wednesday, so we are having the session Wednesday, right? So our regular session, we'll do it on Wednesday. Okay, stay safe. Have a great night. Good night. Okay, bye bye.